Right, so it's the last talk of the day, so hopefully I'll keep you all engaged. So this is keeping code consistent and why that's especially important with a new language like Elixir. As Willie mentioned, I'm Ben. I'm the lead developer at Bleacher Report. For those of you who don't know, Bleacher Report is the second biggest sports platform in the world behind ESPN. It's been around since about 2008. What made it unique at the time was that you could follow your teams locally, professionally, and even players as well. So that made it really unique for the time. And it started out in 2008, which meant obviously that the web was very different at that time. It was a much more passive experience. You didn't get push notifications. You didn't constantly interact with your content. You signed up for a newsletter. You went to a website. If breaking news happened, you got an email about it maybe, or you just constantly checked the site. And for those of you who are familiar with Bleacher Report, you can see that we have a new logo and a new design. And this is really a culmination of 2 years of effort, both on the front end and the back end. So we managed to take the whole system and rewrite the majority of it on the back end, and then the front end is consistent across all of our apps. So it's been really great. And it shows all the hard work that we've done. And so as I mentioned, why Elixir? Like, why would we choose Elixir? And part of that I just alluded to in the fact that you can do push notifications, and it's a much more interactive web. So in the beginning, October 2014 was when we adopted Elixir, or rather when we made the first commit. Elixir 1.0 had just been released. And I just looked back, as Josie mentioned this morning, it was in September 2014. And when I was preparing this talk, I looked back at the first commit that we made, and the differences in the mix file were quite remarkable. The conventions have changed quite a lot. For us, it was a bit of a gamble because Phoenix it was about a year before Phoenix went to 1.0. But for us, it was a necessity. As I've alluded to already, that the web was much more interactive on demand. And the problem that we were having was that as our traffic grew, we had to keep adding servers and doing all these things. And adding servers only works so well for so long because eventually either the money expires or it just won't keep up with it. And as a developer, it's also not really that encouraging when the only solution to your problem is to add servers, because part of the reason that, the majority reason that we do these things is because we like writing code. And if your code can't handle the traffic, then that's sort of depressing and sort of reflects badly on you. The second option we did, as most companies did, and these are common patterns across the industry, was to use various caching strategies. And that works pretty well until it doesn't. So especially with our system, we had long-running cache, maybe like tags or league standings, these kind of things. You had short caches like scores or content. And it worked well enough to keep the system running, but we still had lots of problems. And the problems were the most when we had breaking news. And this is when the system needed to be the most resilient, because if you have breaking news, people come to your site, the site has to stay up. If it doesn't stay up, they'll go to a competitor and they probably won't come back to you. And we evaluated a number of languages when choosing Elixir, before choosing Elixir, but the reason that we initially thought Elixir is great for all of the bullet point reasons that we know. It's scalable, fault tolerant, all of those kind of things, concurrency. But we also had to find a language that we could teach to the rest of the developers, because if you're just there by yourself, it's not going to do it. We have about 12 or 13 backend developers, and if 12 of those backend developers don't want to use the language that we choose, then it's not going to be adopted. So we chose Elixir because it had a familiar syntax, so we felt like people would get behind if we could prove that it worked. So this was the Phoenix guidelines for the version of Phoenix that we adopted. Do what feels right. It's a very laissez-faire approach to software development. And this was because it was really early in the life cycle of Phoenix. I think it was 0.5/dev. CoffeeScript was still part of Phoenix at this point, which is very early on. And there's some benefits and trade-offs when you adopt a framework or language at this stage. First, any language or framework that's pre-1.0 is still finding its way. It's still developing the API and so on. And Phoenix was no different. Ecto, for instance, didn't have change sets at this time. And change sets are one of the most teachable things that we've been able to use to teach other developers about functional programming in Elixir. So at the time, we were just basically taking structs and inserting them in random places and doing these things, but that was okay because it worked well enough and it sort of gave us a footing with the language. And when they sold the Elixir to the company, they didn't mention this part, that it was so early on in the life cycle of the framework. They rather focused on the positive aspects of Elixir and Phoenix. And I joined Bleacher Report to work with Elixir. I was really excited about Elixir. And this opportunity came, and so I joined as quickly as I could. I was hired as a Ruby developer, but I was determined to write Elixir. This was why I went there. And at the time that I started, I didn't really know much about Elixir, other than I'd made some very simple apps. The documentation was changing so frequently that it was hard to keep up, but I'd played with it enough that I really wanted to continue working with it. So I saw an opportunity about a week or two into my employment at Bleacher Report we had a problem with this really simple app that fetched embed data. So we aggregate a lot of our content. We have internal writers, but we also have, we pull in content from Twitter, Instagram, Facebook, other writers, and so on. And the problem was that if we made too many requests to this embed service at the same time, the response time would increase exponentially until it timed out. And this, to me, was like doing lots of simple things at the same time. This seems like an excellent use case of Elixir and concurrency. So it took me a couple of days to sort of port the code into Elixir. And the surprising thing was that it worked really, really well. Whereas with the other app, if you added multiple requests, it would exponentially increase. With the Elixir app, you could add multiple apps or multiple requests, and it would only incrementally increase. And we deployed it to production. Everything worked really well. But there was a problem. The code was a mess. So I'm going to show you probably one of the worst functions in Elixir I've ever written. It's so bad, you can't even see the whole function. Like, if I put the whole function up, you wouldn't be able to see read the code. So, and this function isn't bad for Elixir. This function is bad in any language. I should have known better. First of all, the name is terrible. For what? For URL, what does that do? Second, the inconsistent spacing around the tuple. But you can, and it does, even though you can't see all of it, it does at least 3 things. One is to prepend the HTTP to format the URL. The second is to call out to fetch the embed data. The third is to handle the response. And the fourth is to return a response based on what kind of content it is, if it's Twitter, Instagram, et cetera, video, so on. And you can see that I'm very excited about Elixir because I tried to do all the superficial Elixir things, pattern matching, tuple, pipe, case statement, and conditional, all in one function. So, say you want to teach this. So we have an app that works. It's performing really well. It's something that we feel like will do what we want it to do, and we should invest more time to see if this is going to work out for us. Now, I showed it to someone else. The obvious problem is this collaborative barrier. How do you to show someone this terrible code and expect them to have good standards? Are they going to take that as an example, or are they going to see that it's a mess and not want to invest in it any further? And it's also confusing for me. Because like Andrea mentioned earlier in his talk about documentation, you're writing documentation for your future self and others. And beyond that, it's not extensible. So at the time, we had maybe 6 or 7 content types, and now we have about 15. So what I just had, multiple conditionals, then it would have been about 100 lines long for the function. And you would introduce more bugs as well, potentially, because it's confusing to follow and so on. And one of the things that we realized at this point was we have to sort of codify our Elixir apps. And it took us about 6 months or so to get our first sort of fleet of Elixir apps in production. And by that time, Phoenix was post 1.0, so we felt that it had a long way to go. Elixir was already quickly picking up traction. And the app worked really well, and other developers also expressed interest in learning the language. It was at that time people were really like, I want to learn this language. I want to develop in Elixir. So we had to see. So at this point, we had to decide how we're going to do this. Fortunately, Credo came out around this time, and one of the sort of serendipitous things about the Elixir community is that in the beginning, the answers to the problems came really quickly. So you had all these, and they had all these different solutions so fast. And there are a few other static analysis libraries, but what makes Credo unique, and especially for this purpose in writing consistent code, is that it teaches you by offering explanations. You can see if you get an error, perhaps another linting library doesn't show you why it's bad. It just gives you an error. The developer will try to figure it out, or maybe they'll just go ask you. But with Credo, you can go in and expand it, and it'll tell you exactly why it's doing it. So this is good for 2 things. One, it gives the developer a bit of confidence in the fact that they can figure out the problem themselves and not have to go ask you how to do it. And the second is, of course, that they don't have to ask you or interrupt other people to do it. They can do it on their own. And it also structures the app, like in it also structures the app in a way that is reproducible across other apps as well, because it has a configuration file. And it actually took us a lot of time when we first adopted it because all of our applications were so distinct, and the standards for Phoenix and Elixir were changing all the time. But once we got it in place and once we found out what we wanted to do, it was really easy to standardize because Credo is opinionated like any other linting library should be, but it allows you to make the changes that you need to do to work for you. And it's interesting that as each release of Credo comes out, there are different changes in the linting, which means that, you know, just like Phoenix evolved, just like Elixir is evolving, just like our understanding of Elixir is evolving, Credo is also evolving. So when a new linting or when a new standard is introduced, we have to say, is this right for us, and decide yes or no. But it worked out really, really well, especially at that time when we were training a lot of people. So if you run Credo, it'll tell you that the function I showed before is really bad because it's too long, it's too complex, it does too many things. So with that in mind, we can rewrite it to something like this. So now we have 4 functions. You have 3 private functions and the entry function. It's much clearer what it does. The name is still bad, but you can see exactly what's going on. You take a URL, it formats it, gets the embed data, and formats it by content type. And so each function is basically doing one thing. And another thing that we introduced at this point was having more confident and declarative functions, in the sense that, so instead of trying to guess which type this is, we could tell the function what type it is. So in the bottom function there, you have content type as an atom. So that's a tweet, of Instagram, Facebook, video, whatever. It's declarative. You don't have to guess. And this really reduced the number of bugs we had, especially because in the previous implementation, there's a bit more JSON, some empty fields, and this way we can return only the fields that we need, which made life a lot easier and reduce the number of bugs. It's also much more extensible because now you should add a new content type, and then you can have a new function and so on. And this was one of the things that I really found about Elixir to be really engaging, was that it encourages explicitness. And it's a very expressive language. And so now that we have a better function, how do we add more information around it? And type specs in Dialyzer are, I guess people have mixed opinions on them. I'm in favor of using type specs and Dialyzer because, you know, as I mentioned earlier, it's about expressiveness and about expression. So here we have the same function. One of the nice things about Dialyzer is that type specs is that you can create your own custom types. So now we have even more information about this function. It takes a string and it returns an embed, and if you look above, it's a map. And what's also nice is that it's fairly objective. You know, it'll complain if you do the wrong thing, which in some cases might make it just as good for for simple functions, you don't necessarily need to write documentation, because if it's a sum function, it takes a couple of integers or some number of integers, and it returns an integer. So you have this very clear laid out thing for you to see. And good documentation is great, of course, but good documentation is also subjective. If I look at this function, I know exactly what's going in, and I know exactly what's coming out. It also encourages you to think more about what you're doing with your functions when you have this sort of thing hanging over your shoulder saying, look, you know, I'm watching everything you're doing and making sure that you're doing it correctly. It adds more thought to your function, to how you write your software. There are, of course, some downsides, and this is why perhaps it might not be good for people who are new to Elixir to use it, because you can get perplexing errors. And you have less control over included libraries. So if they don't use them or they have incorrect types, then you might see those as well. So here's a couple of errors. And you know, has no local return is one of the most common things that I've seen in my own code. And it was very confusing because I was like, I don't understand why this is doing this. Then I read around a bit, and it turns out that according to Costas, who's the creator of Dialyzer, that you just have to use a no return type, which is kind of strange because it doesn't, I don't know, it doesn't provide the level of information I have. But the nice thing about that is that it encourages you, if you're the curious type, to go out and see more and learn more about why these things do the things they do. And then the second is kind of overwhelming if you're new to the language. But I think it's worth it because it gives you more control over it. Other thing to be aware of is that you can be, there's equivalent specificity. So both of these functions will, or both of these specs will pass. The one on top, they both return structs. Active.changeSet is a more specific struct than struct. So, which is also nice because you can be as specific as you want. The downside, of course, is that you can be less specific, but the general sentiment is the same, that one is just a more specific version of the other. And I think Fred Hebert, who wrote Learn You Some Erlang, explained it really nicely. Silly me. It turns out that I was wrong and Dialyzer was right all along. It would keep telling me my spec was wrong, and I kept believing it wasn't. I lost my fight. Dialyzer and my code won. This is a good thing, I believe. And this is an excellent explanation of why it's worth the effort to deal with Dialyzer. Especially if you're starting a new project, it's a lot easier to start rather than go back and fill in all the specs, because it can take a lot of time, and especially if you're on a deadline or these kind of things. And the nice thing about it, just like Credo, is that it'll potentially catch things that developers might miss, like in the function I showed at the beginning, when the curly brace had a space in it, Credo would catch that. And just in the same way that on the previous slide showed that the type spec was incorrect on the second bit there, I wouldn't have caught that. So it's nice to have another layer of checking there. And now we'll move on to a little bit more subjective bits. Documentation. The nice thing about Elixir, as I've mentioned before, is the expressiveness and the explicitness. Documentation is no exception. Documentation is the first-class citizen in Elixir. Xdoc makes it extremely easy to write, to have beautiful documentation that's easily readable, and you almost get it for free if you write your documentation. So let's look back at that other function one more time. So now we have some more context. Attempts to fetch and extract embed data for URL and format it according to the defined content type. So that gives you a lot more, a clear understanding of what's going on. And in some cases, I like to write the documentation first. I'll write the function. I'll sort of think about how it's going, but because it gives you a nice mental model of what the function should do and how your data is transformed or manipulated throughout the functions. And it also helps me to write better function names, because you have to, once you explain what it's doing, it's essentially that you give a summary of the functions, what the function will do, then you can come back and change the function name, which is essentially the topic of the function. So now instead of for, whatever that means, now you have fetch and extract embed, which is much clearer and gives you a much better idea of what's going on. And now the URL param, you can see that even someone who's never programmed would probably be able to figure out what's going on. And this is better for everyone. If you come into a new project, you can easily see what's going on. You can easily explain to other people without being there, because you've already written it. And also, I mean, look, everyone who's written code, who's written document, has 6 months later come back and had no idea what the code was doing. So having these things in place is very useful. So this brings us to one more component of consistent coding, which is testing. I mean, testing is fundamental in any setting. And one of the interesting things that we've done at Bleacher Report, so when they hired me at Bleacher Report, it was the sort of the traditional whiteboard interview. It was a Ruby whiteboard interview. I'm not very good at whiteboard interviews, so I wasn't sure if I'd gotten the job, but apparently I did. But we've changed that, and instead of doing that, we try to duplicate or replicate what you would do in a normal day of work. So we give you an open-ended take-home test, but make it very, very general. If you're applying for a back-end position, we'll give you some, maybe you'll write an API or do something with data, these kind of things. And we leave it intentionally vague, and if they don't add tests, then they don't move forward. Because when you interview someone, it's essentially, you put your best foot forward. It's like a first date where each side is trying to figure out, do they like the other side? And this has been like the best predictor for success that we've had so far. So it's really changed the way that we interview candidates and made it much more successful. And of course, the nice thing about testing is that you see if your code works. And this is good for any developer at any level of proficiency, but especially when you're learning a new language, it builds confidence because you can write the code, test it, and even if it's bad code, if the tests pass, then that means that you have a good first rough draft. And you can get it to a working state, and then you can iterate over it much quicker because you have the confidence that as long as the tests pass and the tests are written well, then everything is fine. So how to measure coverage? This is something that we've, of course you can measure coverage by just the number of tests that you have, which is not a very good indicator of what's going on because you can just test one part of the project but not another and so on. Coveralls is another helpful library that we've found that's to be very useful for just that reason. It gives you a nice printout of what's going on. You can see everything that's covered, all the files, and so, but I'm not a big fan of test coverage percentage. I mean, I don't see the need for necessarily 100% test coverage. It depends on the situation, of course, but it's better to focus on the data flow and how the application behaves rather than trying to cover all of the test cases. For instance, you see those things on Twitter every once in a while, or like on the of having two things that work independently well, but when they work together, they fall apart. And so that's sort of the same approach that we take to testing. Is that, of course, it's important to do unit tests for various situations, but if you have to choose one or the other, test how your application flow for happy path, for failure path, and these kind of things. But the one thing that's nice about test coverage percentage is that if you have a low test coverage, that means that something's wrong. Either you're using a lot of code in your application isn't doing anything, or you're not testing it at all. So it's a useful barometer, but it's not 94.6 or 4.4, 96% maybe doesn't make a big difference. And another thing you can do with Coveralls is when you have a pull request, you can see the new code that was tested. So you can run the pull request, you know what the new files are, and you can see the corresponding test coverage. So this makes it very nice to see what's going on, and you can, as a developer, you can cover this, and it helps out a lot to write good tests and to see if the test is actually if you're testing the individual functions or if you're actually testing the flow of the data. So to give a quick recap, these are sort of the four areas that we focused on so far: with static analysis with Credo, and Dialyzer, type specs, documentation, and testing. So we've covered basically everything but the actual code itself. All of these are somewhat superficial elements of testing of an application. And the reason that we do it this way is because this all leads up to sort of the linchpin that pulls it all together, which are code reviews. And this is, I've never worked at a place that hasn't done code reviews, but I can't imagine why you would not do a code review, because it's sort of like an editorial process. Even a great writer is going to have an editor, no matter the skill of the writer, and just like any level of coder should have a good code reviewer, because this is the time to sort of study the application logic and to study what's going on. And having set those standards in place, it makes code reviews much easier, and for both sides. For the reviewer, I mean, I've done this times before, where if you see some little error or typo or whatever, you just mark those because you're in a hurry. You review the code, send it back, and you don't really focus on what's actually going on in the application. So by offloading all of this and by having this consistent process across all of our pull requests and code reviews, it makes it a lot easier. In addition to that, we have service reviews before an application is deployed to production, and measure database performance, logging, monitoring, and a bunch of other things. And the reason that we do this is because it makes it very easy and almost boring habitual, because you can just say, okay, we literally have a checkbox to say, have we measured database performance? Have we load tested? Do we have the right monitoring in place? And for most of these things, they're the same across the apps. Depending on the function of the application, maybe you have different metrics or these kind of things, but for the most part, these are just checkboxes and becomes boilerplate. And another thing that's helpful with code reviews are CI hooks. Of course, we use Credo. We have Credo check to make sure that the style is correct. We have X coveralls to show the test coverage and to show the changes on that. And all that leads back to the focus on the code. And as I mentioned earlier, it's much easier on the reviewer. It's much easier on the developer. And you can, it's pretty remarkable how much easier it is to talk about the code rather than to worry about whether you have these standards in place. You can focus on, especially when you're learning a new language, or even if you're proficient in a language, you can find bottlenecks, you can teach best practices. And since we have these things in place, and this is what we did earlier with when we were training developers to do this, we would have them write essentially a rough draft, have the test coverage in place, and have all these other things in place. And then we would sit down with them and we'd show, because we were traditionally a Ruby shop, they would write very sort of Ruby-ish Elixir code, which worked well enough, but there's, you don't want to carry the bad habits from one language into another language, or rather take idioms from another language and try to sort of force them onto another language, like that image that Jose showed of the alphabet and trying to jam the wrong letters into the different outlines of the letters. So it gave the developers a lot of confidence as well, because now they can go back and they can redo it. And it took us, I think it took on average about 2 to 3 weeks for most of the developers to become proficient enough in Elixir to start writing their own code and to not have to have these in-person code reviews and go back to the more less formal GitHub reviews. And it's pretty remarkable because all of our backend developers now use Elixir, and some of our front-end developers are using Elixir as well. So it must mean that this is working somewhat. And one of the most rewarding things and ways to see if this is actually working is when the reviewer learns from the newer developer. It's really cool to see, to have your own assumptions challenged by the way that they've tried to do things, because they've learned Elixir, or they bring other things in from other languages or other ideas that you hadn't thought of. And so it becomes a two-way street. And it shouldn't be an intimidating process. I mean, I remember the first time that I had a code review at Bleacher Report, I was very nervous because this is the first time, I'm showing them, this was in Ruby code actually, but I was worried that I would be judged because we didn't really have these sort of standards in place at the time. So maybe the way that I was doing it was really wrong, and they would be like, why did we hire this guy? This is a mistake. But now that we have these standards in place, it's much easier for this to happen and for it to be a successful process. So now with that said, we have code reviews and the 4 sort of standards that I mentioned before. How can you measure this success? How can we look back over the last year and a half and see how we've progressed, and if these things are worthwhile, and if they're improving our stack, and so on? I doubt that anyone would argue, with maybe the exception of type specs, that these are all useful, but is it worth doing it? First of all, it's an ongoing process. Not all of our applications, as I mentioned, use type specs. And our coding style has evolved greatly in Elixir over the last year and a half. So I think of our standards as being viscous, where they're sort of slow-moving. We have foundational things, but they can change over time. But that being said, once we have these standards in place, all the test documentation, the code style, it's all the same. It becomes habitual and predictable. So that makes it so much easier to move from application to application. And so every year, the NFL draft, for those who aren't familiar with this, we have American football. One night in April, they draft the first round. So each of the 32 teams drafts a player. And I'm not a sports fan, so I don't really understand the hoopla behind this. But every year, this is consistently our busiest night of the year. And in the past, you can scale up because it's going to be busy. You can do all these things to handle it. But conversely, in the past, that I mentioned, the problem that I alluded to earlier was that you can't predict breaking news. So that was where the system really was having trouble struggling. Elixir, however, has proven to be a godsend for us. I'll give you an example of that. Kevin Durant, who was playing for the Oklahoma Thunder. No, it's kind of funny actually. Now that I've been working in a sports company for a couple of years, I know more about sports than I ever thought I would in my life. So I have these little anecdotes. So Kevin Durant played for the Oklahoma Thunder, which is an NBA team, and the Golden State Warriors are the local sort of Bay Area team. And the previous year, the Warriors and the Thunder had this very long, drawn-out playoff. It was very, very testy, and the Warriors won in 7 games, and there's a lot of bad blood between the two teams. And then Kevin Durant became a free agent, and to everyone's surprise, he decided to join the Warriors. People in the Bay Area were very happy. The Warriors are already a good team, and now they're an even better team. And people in Oklahoma were, of course, furious and burning jerseys and effigies and all these kind of things and whatever they do. It was a normal day at work. We were just typing, working on whatever, and it wasn't later until someone realized that our traffic had tripled or quadrupled within a couple of minutes because people flooded the site. And no one knew that it happened at the time. In the past, this would have caused problems. We would have had alerts going on. We would have had issues with the platform itself and these things. But we looked back, and the response time was hovering around 100 milliseconds. And it was kind of another testament to Elixir is sort of this traffic-independent response times where Bleacher Report's traffic is very cyclical. People get up in the morning, they check, they leave work, they check. And we have offices in London as well, so it's sort of all the time. But even when traffic spikes, the response time still hovers mostly around 100 milliseconds. And it's been really great for us. So back to the draft. So this was our first year where all of the core infrastructure had basically been migrated to Elixir. Last year was the first year that we had almost all of the important stuff on Elixir, but this year was the first real test of Elixir. All our push notifications, everything that serves the app, scores, basically everything that's important to have this night succeed was on Elixir. So we felt confident because of everything that I mentioned before, but everything has to go right on this night. This is, like I said, this is the state of the union for BR. If something goes wrong, then it's a problem for everyone. And in the past, we've had issues getting everything's mostly worked. For instance, last year we had some problems with caching and this is where caching really bites us. Constant was still being served, but we weren't able to update the information. So if you're coming to the site and you're still getting the same information, then maybe you won't come back, especially when other sites maybe have the information faster. So this year, everyone's on call, everyone's in the office from 5 p.m. to 9 p.m. for the entirety of the first round of the draft. And it's exciting. It's sort of like before you start a race or a competition or something, you're very nervous, or I guess giving a talk as well, you're nervous and you hope it goes well. And the first pick happened. We got the notifications on the phone when they were announced, and someone had the analytics to see the concurrent users, and it was quickly spiking. And within about 15 minutes, we had the highest concurrence we've ever had by about 30,000 users, which is pretty impressive. And the last highest number of concurrent users we had was when LeBron James, the NBA player, went from Cleveland to Miami in the decision special. And we knew this was happening. I wasn't at the company at the time, but this was expected. It wasn't breaking. It was breaking news in the sense that something was going to happen, but it was expected breaking news because there was all this big special about it and so on. So this was a big achievement for us, and I think LeBron went to the Heat 5 or 6 years ago. So it's been a while since we've had this kind of traffic. So let's see, how did we fare? First, this is the traffic patterns from Thursday to Sunday. You can clearly see where the first, second, third, and Sunday night of the draft take place. And then this is traditionally what you would expect. People are most engaged in the first round, less so in the second, less so in the third, and then it sort of goes back to our normal traffic. And each dot is 15 minutes. And the initial, the base of this graph is higher than it would be because people are coming to the site more frequently because of the pre-draft news and these kind of things. So clearly we had a lot of traffic. Let's see how we handled it. On the left is in seconds, so that's, let's see, 50 milliseconds, 100 milliseconds, and so on. So we're hovering around 50 milliseconds. These three sort of spikes are very annoying because even though they're like under 200 milliseconds, well, the highest spike is about a quarter of a second, which is still very good, but I would like them to be all around the 100 milliseconds. At the goal at Lone Star Elixir, Stephen Wintermeyer gave a really good talk about latency and about response times and how people perceive how speedy your site is. And according to Google, 100 milliseconds is where, sub 100 milliseconds is optimal. So unlike the years past where people were frantically trying to keep the system up or dealing with caching issues, within 15 minutes or so, we were eating tacos and playing video games. Once the two picks came on, once we broke the traffic record, we were all just sitting around. It was kind of surreal because you prepare for this thing and then it works really well, but I'm sort of a pessimistic person, so I expect if things are going well, that means something's gonna go wrong immediately. As soon as we relax, it's gonna go bad. We ended up leaving about 2 hours earlier, and we didn't even have to be there at all because there was no ongoing maintenance that we had to do for the Elixir system. And it was really nice as well because the next day we got all these emails from like the CEO, the president, everyone higher up, just effusive praise about all the hard work that we've been doing for the last couple of years on the front end, the back end, the design side, and the content and product side as well. So it's been a great success for us. So I talked in the beginning about the whole point of having code consistency is so that people can move from application to application without worrying about it. So number of contributors should probably be high for applications. So this is a monolith that we've had since the beginning of time. There are 59 contributors. I never use that. I never even cloned the repo, which is great because I was managed to avoid that. It's not fun to work on because it's an 8-year-old project. So here's some corresponding numbers for the first Elixir apps. So the first Elixir app is 2.5 years old. We've had 23 contributors. The OEmbed app, which is the first app with the code I showed in the beginning, we've had 12 contributors. And another app, the Metadata app, we have 10 contributors. And the reason I showed the Metadata app is because we were able to use this time that we had to spend time developing. Metadata app was a way for us to sort of add all this information, like SEO data that Google requested that really helped us out. And I think our number of search impressions was higher than it had ever been. So it was a great success. And having this stable system means that we can spend all this time doing what we love, which is writing, programming, and not worrying about being on call or having to deal with firefighting, because being on call at the beginning of Bleacher Report was really rough. We have intermittent outages or caching issues, and since we have an office in London, that meant you would potentially be up all night or be woken up multiple times to fix the cache or do these kind of things, and now we sleep through the night. It's really a testament to Elixir and the work that we put into it. And it's been good for us because we were featured on Apple News, Google Play, its App Store, and all these kind of things, which further drives this forward. And so that's sort of all of that. And with one last thing, so if you're curious about adopting Elixir, Jose Valim, Bruce Tate, and I are writing a book about adopting Elixir. It's a pragmatic book, should be out later this year. And the whole idea is to take these things that are subjective and that are still evolving, standards are evolving in the community, and to have it laid out for you so that you can do it easily enough. And the whole idea is that you get, if you're trying to convince your boss or your company to use the Elixir, here's the book. This is why you should do it, and this is how to do it, from team building to monitoring to production to deploying and all these things. It sort of covers all standards of Elixir development from a higher level. It doesn't include like Elixir language, syntax or semantics or Phoenix because there are already great books for that. But that's all I've got. So thank you.